Hello, grade 8. In this video, we are going to talk about a special case with a right triangle. We talked before with Pythagorean theorem, and we want to add a new part as a special case with a right triangle. So we have two different triangles. The first triangle is called 30, 60, 90 triangle. We know already that the sum of measure angle inside any triangle is 180. So once we have 30, once we have 90 degrees and we have 30 and we have 60, so we have a specific ratios between the sides. Then the side opposite to the 30 degrees, which is the least angle in the triangle. So the side opposite to the 30 degrees is, we can call it x. If we would say that the side opposite to 30 degree is x, to the hypotenuse, it will be twice this value. Then it will be 2x. And the side opposite to 60 degree, it will be x root 3. Then, if I want to calculate this one by using Pythagorean theorem, if I have this side is x and this side is 2x, so I have c and this one is a and the other side is b. Then, if I have the side opposite to 30 is x and the hypotenuse, it will be twice this one, so it will be 2x, and we want to find the third one. Then we can say that if I want to calculate the third side, so it will be b equal square root x square plus 2x, sorry, it will be subtraction, I'm so sorry, because already we have the hypotenuse and we want to find the leg. So it will be 2x to the power of 2 minus x to the power of 2. Then b equal, this one, it will be 4x square minus x square. Then it will be 3x square. A square root of x square, so we can put x outside, so you have x and then we have root 3. Then this is from where we got x root 3. So we said that once we have the side opposite to 30, so the hypotenuse, which is the longest side in the triangle, it will be twice the side, which this one is x, so this one it will be 2x. If I want to find the third one, so it will be x root 3. And this is a standard ratio. You will find it in any right triangle. And we said that this one, we can call it a special case of the right triangle. So we said with 30, 60, if I will give you a question like this, if I have the first side equal to the hypotenuse, it will be equal 4 because we will multiply 2 by 2. Then 2 multiplied by 2, it will be equal 4. And then I want to find the third side. If you want to use Pythagorean theorem to find the third side, then you are going to say that you are looking for c. So it will be equal square root 4 to the power of 2 minus 2 to the power of 2. It will be 16 minus, we said 4 to the power of 2 minus 2 to the power of 2. It will be 16 minus 4. 16 minus 4, it will be equal 12. I will change 12 to have a number with root or a perfect square number. So we can say that 12 equal 4 times 3. Now we have square root of 4, so it will be 2, and we have a square root of 3. So as we said, the side opposite to 30, if I would say that this one is x and this one is 2x, and the third one, it will be x root 3. Okay, then it was 2 multiplied by 2 becomes 4. 2 times root 3, it will be 2 root 3. Then this is the first type of a special case, and this is an example. We can use Pythagorean theorem to find the missing side, or we can use the constant or the standard ratio, which is x and 2x, and this is x root 3. Another example, if I have 7, so it will be 7, 14, 7 root 3. Another one, I have root 3, multiply by 2, it will be 2 root 3. Root 3 times root 3 to find the other side, it will be equal 3. Then this is a rule with the first special case. Once we have 30, 60, then we can say that this one, we have a standard ratio. In this question, we want to talk about the opposites here in this one. We have 6 and the hypotenuse is 12, right? So we can recognize that this angle, it should be equal 30. So what about the length of this side? So the length of this side, it should be 6 root 3. In this question, I have 30, right? And I have 18, this side equal 18. Then how we will find the answer of the for the both two sides? I don't have the hypotenuse and I don't have the other leg. So we said at the beginning that this side was 18, it was x root 3, right? So we said that this one was x and this is 2x and this is x root 3. So if I want to find the third side now, what we have to do? If I want to find the third side for this question, how we are going to find the answer for this question? Then we will use 18 and then we will divide it 18 by 18 root 3. Again, if I will draw the triangle for you here, and we will remember the rule together. We said that if this one equal 30, right? So we have x and we have 2x, and this one is x root 3, right? So now we have an opposite to 30. I don't know what this, but we have an opposite to 60, which is x root 3. Here in this one, I have 18. So the other side, it should be what? It should be 18 root 3. And what about this side now? It will be what? It will be 36. It will be 9. Then in this case, if I want to change now according to the standard ratio, I have x and 2x and x root 3. Now, once we have a side opposite to 30, we will multiply by root 3. What about if I have the opposite? I have this side. Then to find the side opposite to 30, we will divide it by root 3. Then I'm going to take 18 and we will take 18 divided by root 3. Then the answer, it will be equal 6 root 3. Then this side, it will be 6 root 3. Now I have the side opposite to 30 degree. We will multiply by 2. To this side, it will be 12 root 3. So in this question, he gave us the opposite. Once you have an opposite to 30, we said x, and then times 2 to find the hypotenuse, and then time root 3 to find the other side. What about if you will give us the opposite? So we will use the opposite operation. And instead of multiplication, I'm going to divide. So it will be 18 divided by root 3. It will be 6 root 3. Now I have the smallest side, which is 6 root 3, and I'm looking for the hypotenuse. So we will multiply by 2. So this was the special case, how we can use Pythagorean theorem to work with the special case. Was the first special case. We have a second special case, which is 45, 45. With 45 and 45, when we have a right angle triangle like this, and it's isosceles, so this is a right angle, and we have this one equal, this is 45, and this is another 45, it's isosceles. Here is it. Okay, so if I would say that this one is x and this one is x, so how you will find the third one? It will be x root 2, which means if this side equal 5 and this one equal 5, to the side it will be 5 root 2. How we will prove it? We will prove it by the Pythagorean theorem. The hypotenuse, I'm looking for the hypotenuse. It will be square root 5 square plus 5 square. It will be equal square root 50. Then square root 50, I will change it into perfect square number as much as I can. So we can find that 50 is 25 times 2. We will find the square root of 25. It will be equal 5. So we have 5 square root 2. So this is the second special case when we have two isosceles, or we have isosceles triangle with a right angle triangle, and we want to find the length of the other two sides. This one equal this one. What about if I would say that the hypotenuse was 8 root 2? So this one, it will guide us to know that the first side was 8 and the other leg was 8. So as I said, this is two special case for the right triangle. The first one is 30, 60, 90, and we said x and 2x and x root 3, and 45, I'm sorry, this is 90, and 45, 45, and 90. Best of luck to all of you. See you in the next video, inshallah.